Hello and welcome to today's lesson on angle sum, exterior angles, and triangles with similar triangles. I'm going to share my screen. Okay, so our TEK today is 8.8D. Our learning target is I will establish facts about angle sum and exterior angles of triangles for similarity of triangles. And our essential questions are: what is the sum of interior angles of all triangles? What does the exterior angle theorem tell us? So for the first one, sum means the answer when we add, interior means inside. And the inside angles, if we add them together, should always equal 180 degrees. And then in terms of the exterior angle theorem, exterior means outside. So to really review this concept, I'm going to go ahead and draw a triangle. So I have a triangle. I'm going to extend the line here so that we have an exterior angle. I'm going to go ahead and label it with numbers. So we have 1, 2, 3, and 4. Okay, so our exterior angle here is angle 4. So we know that to get the exterior angle theorem, or to get this angle for the exterior angle, we're going to have to add the two remote or two opposite inside angles. So we can see that number 3 is adjacent. It's next to the 4. So we're not going to use that one. So then we're going to use angles 1 and 2. So we know that if we add angle 1 plus angle 2, that it'll equal angle 4. Okay, so the only new vocabulary word that we have, because we've pretty much been going over all of them, adjacent angles are angles that are next to each other. Complementary angles are angles that add up to be 90 degrees. The C in complementary is C in corner because right angles have a little box in the corner. So there are two angles that add up to be 90 degrees. Then supplementary are two angles that add up to be 180 degrees. So the S in supplementary should remind you of the S in straight line. Exterior angle. So exterior means outside. So it's the outside angle. The triangle sum theorem we just reviewed, that means that the three inside angles, the interior angles of a triangle, add up to be 180. And this is our new one. The triangle exterior angle theorem is also one that we've gone over. So that's that angle 4 is equal to angle 1 plus angle 2. So our new one is the angle-angle similarity theorem. So we have two angles in the vocabulary word. We have angle-angle, so that's two angles, and similarity. So if we remind ourselves what similar shapes are shapes that are the same shape but different sizes. So I'm going to go ahead and draw an example. So we have this one and this one. So what the angle-angle similarity theorem tells us is that if two angles of one triangle are congruent to the corresponding angles of another triangle, because we do know that corresponding angles are congruent, then the triangles are similar. So even if we didn't have this picture, but maybe we had a word problem that said that one of the angles was, let's say, 40 degrees. So we have 40 degrees. And then the corresponding angle on another triangle is also 40 degrees. Then we're given another angle. Let's say one of the angles, this angle up here, is 60 degrees. And then the corresponding angle in the other triangle is 60 degrees. Then we know for sure the relationship is that they're similar. They could be congruent, but we don't have that confirmed, right? Because we don't know the side lengths. But as long as they have the two angles that are the same, that means that they are similar for sure. Okay, so now we're going to move on to our activity. Question 1 says to determine the unknown angles measures in the figure. Okay, so we have 5 angle measures, right? Angle 1, 2, 3, 4, and 5. And so we're going to start with angle 3 right here, because we can see that angle 3 and this 49 make a linear pair or supplementary angle. So that means that when you add them together, they should equal 180 degrees, and that's because they make a straight line. So to solve this problem, we're going to subtract 49 on both sides. And then we have that angle 3 is equal to 180 minus 49 is going to be 131. So angle 3 is 131 degrees. I'm going to go ahead and label that on here, 131 degrees. Okay, so next, So we actually are going to figure out this angle right here. So to do that, I'm going to go ahead and use the triangle sum theorem. So I know I'm going to just label it x, right? So we have x plus 63, which is the other interior angle, plus the 49, which is the last interior angle of this right triangle, has to equal 180 degrees. And so then I'm going to go ahead and use Desmos and type it in. So when I type it into Desmos, remind yourselves that you have to change x and you have to change the equal to sign, right? So I'll tell you what I typed in. So I'm going to use letter A plus 63 plus 49. Instead of the equal to sign, I'm going to use the tilde, 180 degrees. And if I put that into Desmos, I should get that A, or angle X, right, is what it originally was, is going to be 68 degrees. So this right here is 68 degrees. So we needed that angle to figure out the adjacent angle, the angle that is right next to it, which is angle 2 right here. Okay, so for angle 2, we know that angle 2 plus we have that 68 degrees. This is also a linear pair of supplementary angles, so we know that together, when you add them up, they're going to equal 180 degrees. And then, of course, to solve this problem, you're going to go ahead and to subtract the 68 on both sides. So then we have 68 minus 68 is 0 pair. We have angle 2 is equal to, then we have 180 minus 68. So angle 2 is going to be 112. Okay, so then we have 112 right here. So now that we have angle 2 is 112, we can actually use that in the triangle sum theorem to figure out angle 5. Because we know that all the angles on the inside of this left triangle right here have to add up to equal 180. Okay, so to do that, I'm going to go ahead and say 31 plus 112 plus angle 5 is equal to 180. And then, of course, using Desmos, remember to change, well, instead of using angle 5, we can use B, right? So we have 31 plus 112 plus B tilde, the squiggly line in Desmos, is equal to 180. So if we correctly input that into Desmos, B, or angle 5, should be 37 degrees. Okay, so I want to remind us that angle 1 and angle 4 are vertical angles, right? Vertical angles are basically angles that are opposite of each other or across from each other. And vertical angles are congruent. That means they are the same. So whether we figure out angle 4 or 1 first, we know that the other one is going to be the same number. Okay, so I'm going to look at the relationship here. I see that 1, 5, and the 63 degrees all make up a linear pair or supplementary angle. So I'm going to use that to go ahead and write my equation. So we have angle 1, which I'm going to try to figure out, which again I know is the same thing as angle 4. So angle 1 plus the 37 degrees plus the 63 degrees is equal to 180 degrees. And again, using Desmos, all I have to do is change the angle 1. Let's say that's C plus 37 plus 63 tilde 180 degrees. If you type that in correctly, you're going to get that C, or angle 1, is equal to 80 degrees. And if we know that angle 1 is 80 degrees, we know that angle 4 is also 80 degrees because it's vertical. And here was angle 5, which was the 37 degrees. Okay, so then the next problem says, suppose that triangle BHX is similar to triangle KRC. So I'm going to highlight the word similar. Then question 2 is saying list the corresponding angles. So remember that corresponding means angles that are in the same position. So I'll go ahead and write that. Same position. Okay, so to do this, we don't actually need a photo. I know that most times we have a picture of like the shapes. We actually need to just look at the order. So we have the first letters are B and K, so they're actually going to be corresponding, right? Then we have the next letter. The middle letter is H and R. So they're in the same position. H. All right, let me go ahead and write H first. We have angle H and angle R. And then the last one we have is X and C. So angle X is corresponding to angle C. Okay, so question number 3 is asking for ratios. Write the ratios to identify the proportional side lengths. Okay, ratios, as a reminder, is a comparison of two things. So we use the word two, we use a colon, or we write it as a fraction. In this case, we're going to go ahead and write colons. Okay, so with side lengths, we're actually going to need 2 letters, right? Because we need to go from one letter to another letter to get to the side. So I'm going to start with BH. We have BH. The corresponding side to that is going to be KR. And they are going to be proportional because they are similar. So that means their scale factor is going to be the same. So if we think back to dilation with the shape getting bigger or smaller, the number by which it gets bigger or smaller is going to be the same for all the side lengths, is what proportional means. Okay, so then we're going to do the next one. So we did BH, now we're going to do HX. We have HX. So that's the middle and the last letter. So then on the other triangle, that's going to be corresponding to RC. So the middle and the last letter on the second triangle. Then I'm going to do the first and the last letter. So we have BX is corresponding to KD. Okay, so then we have this last part, which says you have determined that when two triangles are similar, the corresponding angles are congruent and the corresponding sides are proportional. Okay, so from here, two triangles are similar, corresponding angles are congruent, corresponding sides are proportional. If you guys remember the vocabulary word that we went over at the beginning, that is called the Angle-Angle Similarity Theorem. Okay, so this is a real-world connection. It says graphic artists use knowledge about similarity to create realistic-looking perspective drawings. Choose where the horizon should be and a vanishing point, a point where all the parallel lines in the drawing should appear to meet, and you too can create a perspective drawing. Okay, so question number 4 says, suppose the vanishing point is point A, and that DE, this symbol right here stands for parallel to BC. So you can see DE, BC are parallel. How can you demonstrate that triangle ABC is similar to triangle ADE? Okay, so we have triangle ABC, which is this big one right here. And I'm going to go ahead and label this upper part the vanishing point A, because that was mentioned in the problem. And then, of course, we have ADE inside. That's the smaller triangle. Okay, so we have the smaller triangle, then we had the larger triangle. Okay, so we're going to start off with naming one side. So I'll go ahead and start on the bigger triangle. So I'm going to say AB. So we know that AB is corresponding. It's on the left side, so we see that AD is also on the left side, just on the smaller triangle. Okay, the next one, we'll do the base, the bottom side length. So on the big triangle, it's BC. So we have BC is proportional to DE. Okay, and then on the last one, we have, let's say AC is corresponding to AE. So up here for problems 2 and 3, we didn't have a photo. We just had like a verbal statement, a verbal description. And then down here, we have the pictures, right? And so either way, you can figure out what sides are corresponding, what angles are corresponding, just from, you know, the way that the triangle is given to you, the order of the letters. Because you can see AB is the first 2 letters right here, AD is the first 2 letters right here. Then we have BC is the second and the last letter, and then DE is the second and the last letter. And of course, we have AC, which was the first and the last letter, and then AE, which was the first and the last letter. Okay, so then this next problem is saying, given that line BD, so that's the sign right here, is parallel to line HG, that's the sign right here. Then it says AH, which is the sign right here, is parallel to DF, which is the sign right here. Then the symbol right here stands for perpendicular. So perpendicular means that they meet at a 90-degree angle. Okay, so 2 lines meet at 90 degrees. That's what perpendicular means. Okay, so to show you how it looks like on this picture, we have AH, which is this one, is perpendicular to AG, which is this one. And then our next one is, we still have that perpendicular symbol. We have DF, which is this one, is perpendicular to AG, which is this one. Okay, so we have two right angles right here and right here it was. So now we can answer the questions. So question number 5 is asking, is triangle ABC, I'm going to go ahead and highlight that, ABC similar to triangle AHG? So AHG, this one. So remember that similar triangles are shapes that are the same shape but different sizes, right? So these are two triangles that are the same shape, different sizes. So yes, these are similar. Okay, we still have ABC for the next one, but now it's comparing it to EDC. So EDC right here is right here. So we can see that they're both triangles. They meet at this point, point C, but we can see that, yes, they are similar because they are both triangles, just different sizes. Okay, next we have EDC. And then it's being compared to EFG, which is this one right here. So these two triangles definitely could be similar, right? But it also looks like they're more congruent because not only are the same shape, but they also look to be the same size. Okay, the following question is asking, is triangle ABC similar to triangle EFG? Okay, so we have ABC, and then we have EFG, this one right here. So it looks like, yes, they are similar because they're both triangles. They're just different sizes. And then the last one is saying, is triangle AHG similar to triangle EFG? Okay, so we have AHG, then we have EFG, which is right here. Okay, so yes, because again, both triangles are the same shape, just different sizes. Okay, we're going to move on to our first we do. So for this we do, it says in the diagram below, lines A and B are parallel. So you can see lines A and B are parallel. Then it says line T subscript 1 is perpendicular to lines A and B. So that's this one right here, because we also have T subscript 2, which is the transversal. Okay, so we know that if it's perpendicular, that it meets at 90 degrees, right? So we're going to go ahead and write perpendicular, 90 degrees. We're going to draw a little box in the corner. And then it gives us more information. It tells us that the measure of angle 3 is 45 degrees. So near angle 3, I'm going to go ahead and write 45 degrees. Then the question is asking, based on the information in the diagram, what is the measure of angle 2? Okay, so we're basically figuring out, or trying to figure out angle 2, which is right here. So you have angle 2 plus angle 3, which is the 45 degrees that we know of. We know that it equals 90 degrees. And of course, to solve this problem, we're going to subtract 45 on both sides. 45 minus 45 is a 0 pair. So then we have angle 2 is equal to, then we have 90 minus 45 is 45 degrees. So we have angle 2 is 45 degrees, but because this is a multiple choice question, we see that 45 degrees is B. Okay, then the next we do says in the diagram below, figure RST is a right triangle. You can see it has this right angle in the corner right here. Then it says, based on the information in the diagram, what is the measure of angle RST? So we have R to S, S to T, right? We're trying to figure out what angle they're actually asking for us to find. And that's going to be angle S because that's in the middle right here. And we see that S is actually X, right? So we're going to use the triangle sum theorem where we know that the interior angles, the inside angles of a triangle add up to equal 180. So we have X plus, we know that this right angle right here is 90 degrees, right? So X plus 90 plus X minus 10 is equal to 180. Okay, so this time I am going to show you on Desmos how to type in this equation to get the answer. Remember that we have to change two things. We have to change our letter, our variable, and we have to change the equal to sign to a tilde. Okay, so I'm going to go ahead and write a instead of x. So a plus, we have 90 plus a minus 10 tilde the 180 degrees. So remember that you can find the tilde on your screen. It's right here at the bottom. Okay, so we can see that a, or in our case x, is going to be equal to 50 degrees, right? So we have x is equal to 50 degrees. And then, of course, in our answer choice, 50 is letter C. So the rest of the worksheet is the you-dos and the independent practices. Thank you so much for following along in today's lesson, and see you in the next one.